Good morning. Today we are going to start chapter number 7, Congruency of Triangles. So in this we will study some more properties of triangles and we will prove how to congruent them. First, what do you mean by congruency? If we superpose one figure to over other and they fit into each other, then they must be congruent shapes. What does it mean? What is the meaning of superpose? Superpose means if we place, suppose this is the figure, United States ticket. If we place this figure into this and there each corner will place or cover the second one's corner, that means the figure is congruent. Okay, so here you can see this is the symbol of congruent, equals to sign, and upon this there is a similar sign. Together they form a symbol of congruence. Congruence of 2D shapes. 2D shapes means two-dimensional shapes. How you can say a triangle should be a congruent? I repeat, how you can say triangle should be congruent. The first thing, their base should be equal. What is base? The bottom of the triangle should be equal and altitude. Okay. Second thing, their all three sides should be equal. Or their two angles and one side should be equal. Like this we can make a triangle congruent. We will study about it later. First, we will begin with congruence among line segments. How a two line should be called as congruent. To check whether the line segments are congruent or not, we can superpose one line segment over other. Okay. The first thing I already told you to check either the figure is congruent or not, we should superpose the figure to one another. And if it covers completely, then completely from both the sides, from both the shapes. Okay. Then the figure should be called as congruent. So if we talk about the line segment, if the measure of two line segments are equal, then the two lines are said to be as congruent. Here we have seen the definition. See, two line segments are congruent if they have equal length, and if two line segments have equal length, then they must be congruent. Now, congruence of angles. Two angles of the same measurement are congruent, and if two angles are congruent, then their measurement must be the same. If the angles, the measure of the angles are same, then the angles are congruent. Otherwise, it is not congruent. Here in this figure, we can see that both the angles have 155-degree angle. The measure of both the angles is 155 degree. That's why in this condition, these two angles, angle R and angle Q, are congruent. How we can write this? We can write like this: angle R is congruent to angle Q. Now we are going to discuss about congruency of triangles. There are generally four conditions. First, if we talk about the sides, then two sides and angles. Third, one angle and two sides. And fourth, the congruency of right angle triangle. Okay. So in this part, first we will discuss about the cases of congruent triangle. If two triangles are congruent, if we are saying that the two triangles are congruent, then what are the conditions they have? All the sides of one triangle must be equal to corresponding sides of another triangle. It means that all the sides of one triangle is equal to their corresponding sides of another triangle. So what do you mean by the corresponding sides? Corresponding sides means which looks similar. Here we can see that AB is similar to FD. Okay, and they should be equal, and they are known as corresponding side. Similarly, AC and FE are corresponding side, and here BC and DE are corresponding sides. Is it clear? So here in this triangle we can see that if triangle ABC, this triangle, okay, is congruent to triangle FDE, then the corresponding vertices are A, F, B, D, C, E, whereas corresponding angles, angle A and angle F, see, two marks are there, then angle B and angle D, and angle C and angle E. Whereas if we talk about corresponding sides, then AB, FD, AC, FE, BC, and DE. These are corresponding sides. Okay. If the order of the letters in the names of congruent triangles which tell the corresponding relationship between two triangles change, then this corresponding properties will also change. Okay. So there are basically, I told you earlier, basically there are four criteria. One of the criteria is side, side, side. If the corresponding sides of one triangle is equal to the corresponding sides of another triangles are equal, then the triangles are congruent. Okay. Here, if we can say that AB is equals to DE, AC equals to DF, and BC equals to EF, then these two triangles are congruent. Okay. Here you can see the example. BC and FE 5 centimeter, AB and DF is 9. AB and DE is 7 centimeter, and AC and DF is 9 centimeter. So basically, what are the corresponding sides? The corresponding sides are BC and FE. Then AC, DF, AB, and DE. These are corresponding sides. By this, we can say that their corresponding sides of one triangle is equal to another. Then the triangles are congruent. And how you can say the congruent properties? Start from the B. Okay. B, A, C. BA is 7 centimeter, then C. So here how you can do EDF. Okay, EDF, triangle BAC and triangle EDF. Or you can do like this BCA, so FED. So like this you can write the corresponding parts of the triangle. Second criteria is side angle side. As the name communicates, first side, then angle, then another side, and these three will be in continuous manner. See, the side, then angle, then again side. Here also side, then angle, then again side. The criteria says that the two triangles will be congruent if the corresponding two sides and one included angle are equal. One included angle. So these are the arms of the angle. Okay. So we need the two arms should be equal of the same angle. Okay, if we talk about angle B, then these two arms should be included in this criteria. If we talk about E, then these two arms will be included in this criteria. Okay, so here we can see that side AB is equals to DE and BC equals to EF, and angle between them is angle B is equals to angle E. So this triangle will be congruent with the criteria SAS. Okay. So if take here see one example. If triangle JKN in triangle JKN, JK is equals to KN. Okay. Then AK is the bisector of angle JKN. This is angle JKN, and this line AK is the bisector of it. It means this dimension, this side AK is divide this angle into two parts. So here what we get here, JK side equal, then JKA this angle and this angle is equal, and afterward third one is what, AK AK is common in both the parts of the triangle. Okay, that's why these two parts are congruent. Yes, by SAS. Does angle J is equals to angle N? Yes. Why? The corresponding part of congruent triangle. We can say this as CPCT. Here we have the solution. You can match with this triangle. Okay. The three pairs of equal parts are JK and KN. Then angle JKA. Which angle? This is JKA and this is NKA, and AKA common side. By this SAS rule, this triangle should be congruent, and angle J is equals to NY, corresponding part of congruent triangle CPCT. Now next is angle side angle. This says that two angles and the angle formed on the side, okay, should be equal. So here what are the two angles? First angle is S, and here, so here first angle is B and second angle is C, and here in this B dash and C dash. So these two angles forms on the common arm BC. Here also B dash and C dash. So these two angles and these sides should be equal for this criteria ASA. This criteria says that the two triangles are congruent if the two adjacent angles and one included side of one triangle are equal to the corresponding angles and one included side of another triangle. So here we can see that angle B is equals to B dash. How we can say that? Because here we have one mark and here also we have one mark. BC is equals to CA. Okay, BC is equals to E. Sorry, there is no side EF. So here you can say BC equals to B dash and C dash. Okay, and angle C is equals to C dash. So triangle ABC is congruent to A dash, B dash, and C dash. Like this here also, Ln equals to NO, Mn equals to NP, and LNM and PNO are equal. Why? Because of vertically opposite angles. Here we have the solution. You can check. Now the last criteria, right angle hypotenuse side, RHS criteria. What this criteria says? This says that the two sides, okay, among the two sides excluded hypotenuse should be equal. Okay, so here we have taken BC and the EF. Okay, in this triangle we have BC and this triangle we have EF. And second thing, the triangle should be right angle. Okay, the triangle should be right angle triangle. So these two are right angle triangle, and take one side. Right angle, the triangles have right angle. Hypotenuse should be equal. In this, AC is equal to DF and any of one of the side. So here BC is equals to here. If these conditions are true, then the triangle should be congruent with RHS criteria. Here you can see the examples. After this, there's one question in your book. Is there possibility that a triangle should be congruent with AAA criteria, as we can see in this figure. AAA, what is AA? Here we can see that this angle is equal to 60 and this is also 60. This is 60 and this is also 60. This is 60 and this is also 60. But the sides are different. Okay. So is it possible that these two triangles are congruent? Definitely no. Why? Because we can see that if we superpose this triangle on this, so it lie inside of it, not it will cover this. Clear? The first reason is, second thing we have studied, we can notice that these two triangles are not equal, but they are similar. They are similar but not equal. Okay. That's why AAA criteria is not possible for the congruency of triangles. So that's all for this today's class. Tomorrow we will begin with exercise. That's all for the today. Thank you and have a good day.